Welcome, students, to Emerson's Best Science Room S1. Every year for about the past, almost all of 30 years of my career here, I have had my students do a fire experiment on the very first day of school. Today is your very first day of school for this virtual year, at least the start of the year. And my belief is that in the second half of the year, you'll be back in school so you can actually do this experiment yourself in person with your table group, your lab partners. So this is an introduction to what I hope you'll be doing later in the year. What we have is a fire experiment, which, as you might remember, there's such a thing called the fire triangle. And that triangle requires, says that every fire requires three things. You might know the three things. One, I'm holding in my hand. It's a source of sparks. It's called the flint starter. You'll get to use those too when you're here. The other thing is the what's burning. It's called the fuel. And we're going to introduce the fuel through this tubing and the straw. And this cylinder is going to be where the fire happens. At least the ingredients for the fire are stored. The fire, you'll see, is going to happen. This can has one hole at the top and one hole at the bottom. Okay, and then the third thing we need is oxygen, and that's going to be from the air around us. So I think I am ready now to do the experiment. This is called since you're going to be doing rockets too, if we ever get back here, which I think we will, this is called the Pringles can rocket. Here it goes. I'm going to introduce 5 seconds of natural gas into the can. 1001, 1002, 1003, 1004, 1005. I pull out the tubing, and I'll always emphasize that for you guys when you do the experiment, and then I'm going to light it at the top. There. Now we have our experiment going. I'll move anything that could possibly burn away from it. Typically, we'll be doing this in the middle of each of your lab tables around the room. There's 8 lab groups in this room. And that occurs to me. This is the last year, likely, we'll be using this room, except on special occasions, perhaps, because we hopefully will have new science buildings in place in the next year, 2021. You'll notice if you're observing closely that the flame is gradually changing. It's getting smaller and smaller. And you also may notice another change, that the color is changing from orange to mostly blue. Now that flame is a lot like a fuse. The shorter it gets, the closer it's getting to causing the reaction, which we call an explosion. It's a small controlled explosion. We're getting close. So I'm going to stand back a little. It's very close. So close. Holy moly! There, we had the predicted outcome there. The flame went inside the can, caused an explosion, lifted the can off the table, and that's what we call the Pringles can experiment. Now, oh no, I think. Okay, students, you saw the control experiment. Now we're going to do the experiment itself with what we call an experimental variable. The variable in this case is 3 holes at the top of the can instead of just 1. Everything else I'm trying to keep the same. Same can, same hose, same gas valves, same fuel. So let's see what the effect. If you're thinking about this and kind of making a prediction in your head, that's what scientists do when they're forming a hypothesis as to what they predict will happen. Since you have no experience with this, though, it'd be very surprising if you actually predict what is going to happen. So let's go ahead and do the experiment. Add the fuel, 1001, 1002, 1003, off. Pull out the tubing and light it at the top. There we go. Oh, there's something different already, isn't there? The flames aren't as tall. Maybe you predicted that. The color of the flame is essentially the same, orange, at least at the beginning. And let's just wait and see. We're getting the same effect too. The three shorter flames are now changing from orange to blue. That means something scientifically. You'll find out when we study more about this chemical reaction we call fire. Now the flames are very small and completely blue. What? I didn't predict that. Did you? Instead of the can leaving the table, it just stayed there, and the trapped gases inside just shot out through the whole three holes. See, that's the beauty of science. It's oftentimes really surprising what happens. Excuse me. And I was surprised in this case.